Today I'll be presenting my molecule project over vitamin D. And what vitamin D is that it's the essential chemical compound that's synthesized in our bodies from the sun, or it can be taken as a supplement. And what it's used for is it's used to regulate the absorption of calcium in our bodies. So that promotes bone growth, teeth growth. It also supports the development of our immunity and muscular systems. So the Lewis structure here, structure of vitamin D contains carbon, oxygen, and hydrogen atoms. The vitamin D structure contains double bonds, cyclopentane and cyclohexane groups, which you can see as the full shapes that are closed, and as well as double bonds you can see towards the bottom and the top. And the structural makeup of vitamin D shares a close resemblance to steroids. Here's a picture of ethanol, but really I'm just showing off the squared OH, which is the hydroxyl functional group, also alcohol. So vitamin D structure contains this functional group. It does not contain any oxygen to carbon double bonds, which eliminates ketone, aldehyde, carboxyl, and ester. And the vitamin D also does not contain any nitrogen or sulfur atoms, so it couldn't have any amines, amides, or thiols. Right. And moving on to the chiral centers. The chiral centers are identified in objects such as hands that have non-superimposable mirror images. Achiral centers are identified when the mirror image of an object is identical and can be superimposed on the original. And the structure of vitamin D has two identifiable chiral centers, one at the middle top and one to the right of it. And they're connected to four different groups. And so we're taking a look at the one on the left side. It's attached to carbon and hydrogen 3, and also a hydrogen, and also a carbon hydrogen 1, but then also a other carbon hydrogen 1. But my understanding is that because those are two separate wings that are different, then that is why they're still considered chiral. So moving on to the next slide, molecule solubility in water. Vitamin D is not a water-soluble molecule. There are vitamins such as vitamin B and C that are water-soluble. Vitamin D is a fat-soluble vitamin, meaning that the human body uses fat material to break down, digest, and utilize vitamin D. Vitamins A, D, E, and K are the common fat-soluble vitamins used in the body. Molecule biofunction. A lot of good information here. It's a fat-soluble vitamin that is present naturally in few foods. It's often consumed dietarily by being added to food or being taken as a supplement. Vitamin D is produced inside the human body when the skin absorbs UV rays from the sunlight, thus triggering vitamin D synthesis. Vitamin D obtained from sun exposure, food, and supplements is biologically inert and must undergo two processes of hydroxylation in the body for activation. And what that is the synthesis of vitamin D. So when we're getting it from the sun, we're not just getting vitamin D from the sun, right? So we're getting we are getting vitamin D from the sun, but not the way that our human body utilizes it. So we're putting it under the synthesis, just like plants would, right? So plants receive energy from the sun, and then they break that down through photosynthesis into their food. And photosynthesis, I believe, is a way to take vitamins from the sun, which is their nutrients. So vitamin D promotes calcium absorption in the gut and maintains calcium and phosphate levels to enable normal mineral deposits in bone. Vitamin D is needed for bone growth and bone remodeling by the bone building and breaking cells known as osteoblasts and osteoclasts. And those are the cells that are within bone that move around to shape the bone as somebody grows, right? So could be wider, thinner, and they come through to shape and form it over time. And additional information on vitamin D, the consumption of vitamin D supplements has been researched and shown to produce health issues for users over time. Excuse me. So it is safer to acquire vitamin D naturally through sun exposure rather than through tablets. And I actually have vitamin D tablets, and now I know this information, so I take it less often, and I don't overload on them, as I would suggest that to anybody now that I've read about it. Vitamin D is a vitamin distributed into different types, similar to vitamin D, right? So vitamin D2, vitamin D3, there's different names for these, and they're not the same, but they're still branched from vitamin D. So, and here's my reference page, and thank you for watching.